Hey drivers, we've put several hundred miles on this 1600cc single port rebuild and everything seems to be going pretty well, but everything that we did after assembling the long block got done in a terrible hurry and we really need to go back through and tighten a few things up. I'm betting that there's some budget rebuilds out there that could probably use the same kind of attention, so come along with me, we'll see what we can find and see what we can do about it to keep this thing running smooth. I already pulled the exhaust off. I wanted to try out a couple of 4-into-1 exhausts that I had laying around, and it didn't really go too well. I even have a can of exhaust restorer here. But they just didn't seem right for the application. So we'll just keep the buggy exhaust that we've been running and maybe keep an eye out for some stuff in a swap meet here in the near future. I do want to clean up and use this air filter. It's a little bigger, so I think it'll flow a little better than the small one that's on there. I didn't tighten the fan well enough, and I think I've probably messed up the hub, so I have this one on standby just in case we need to replace that. I will be putting the thermostat and flaps into the shroud because I'm a firm believer in this. We'll discuss that when we get to it. And I did come across a couple of industrial tins here, one of one side and two of the other. I'm going to see how these fit compared to the homemade jobbies that I've got on there now. These would be a whole lot easier to fabricate than the way I did it. We'll do a comparison when we get there. We've already put an in-out pump on here, so now we have a filter. I wish I'd had this from the start, but things got a little crazy there towards the end, and I'm glad to finally have that now. It is a little bit too close to the exhaust, so I want to work this issue out, if at all possible. We have a vacuum leak. I think it's because this is not seated correctly onto the head and it doesn't line up very nice. That messed up how the heat riser lined up with the exhaust. We have a lot of fitting to do there. And then finally, the nut that goes here on the top left, I need to put a captive nut in there. We're using a doghouse fan shroud now on an early case which did not have that, so we're going to bore that hole out big enough that we can put this captive nut in there. Because right now I'm running with only 3 mounting bolts. Don't tell anybody. First things first, we're gonna pull the engine and get it onto the stand. Getting the feeling this thing runs really rich. When I played with the exhaust the other day, I just put the top nut on here and look at all the soot just in a few trials that showed up on the bottom of this gasket. I did the same thing over here and you don't see that much, so maybe the vacuum leak is on this side and the whole thing's running rich. I didn't do anything with the carb. This was on the car before, but it was a dual port. And that engine was kind of loose, so it was probably running rich just to get it to run. Now we have a single port that's not going to flow as much. I'm betting whatever jets I ended up with in here are too big for this application. So this thing probably running a bit rich. The cylinder head temp cinder back here. Need to remove that plug to get that out. I really don't like that arrangement, but it's what there is. I especially don't like this, the tendency of this thing to get all twisted up. I think it's boogered up and kind of stuck to the threads of the spark plug. So if I can get this out without destroying it, I think I'm going to open up that hole a little bit. Yeah, that's a little sooty. And it's not wet, but there is a lot of soot there. For the fuel line, we have a little trick. Those of y'all that have been here for a while have seen this, but for those who haven't, we added a little bit of a hatch in the luggage compartment of Dweezil, and we used stock VW parts to do it. Check this out. This is the engine hatch from a Type 2 starting in 1973. I think everyone who has a 72 wishes they had one of these in their bus. I did this because all of this was Swiss cheese in this car. These sections are available from parts cars or in the aftermarket, but they're always expensive. So I just went this route. Also had to fabricate all of this part up here. You can kind of see my weld line there, but all of this is fabricated, and a lot of that as well. There was a lot of rust back here. So we took a little artistic license. Anyway, this is gonna make it easy to release our fuel line right here and plug it. Okay, I think I've remembered everything except what I'm forgetting. Our first improvement will be installing this captive nut here. This is a M10, of course. Goes in the top left-hand side of the late cases. I have an early case here that didn't come with it, and the hole is too small, so we're gonna have to drill it out so that we can get this thing pressed in there. It's got these ridges in it. It's knurled, or whatever you want to call it. That holds it in place so it doesn't spin, but I got to get the dimensions right. And so I've measured this thing, and I find that it is 0.536 thousandths of an inch. So 536 thousandths of an inch. That's of course bigger than a half of an inch. So we're gonna have to at least go to there. I have a 17/32 of an inch drill bit, and I'm gonna try and stop here. It's actually a little bit small. It's measuring out to be about 528 or so thousandths of an inch. But I'm doing this by hand. I may wobble enough that the hole ends up big enough. We're lacking about 8 thousandths of an inch, and if I go up to the next drill bit that I have, it's probably going to be too much. So let's just see how it goes. I found that a 7/16 just passes right through. 1/64 of an inch bigger than that, 29/64, I think. Yep. Actually, it's gonna bite a little bit. So I'm just gonna approach it that way. Use as small of a drill bit as I can, all the way up to 17/32 to try and get a piloting effect. Try and keep all of this just as straight as I can. Okay, this is 1/64 of an inch bigger at 15/32. Now I'm jumping up to a 1/2 inch because it's what I've got. Okay, the last 1/64 of an inch here, hopefully. Okay, yeah. That, you helping? You see? Yeah, you wanted to see? Okay, this seems to go in, at least right there, nicely, and it bottoms out on the knurling. That's really good. Now, of course, I need to put it on the other side. You could drive it in, I guess, but since it's threaded, I'm just gonna pull it in nice and easy like. I'll just need to work out something over here. The problem I have is this ridge. I'm gonna use just a regular M10 here, but I want it to be flat against a surface. That ridge is in the way. So I'm gonna use a washer, I think, and I'll have to put some kind of a spacer that's the depth of that ridge there on the other side of the washer, just to get me by. I only need this to work once and then I'll be all set. I have my caliper again. I need to zero that a little bit. There we go. And I'll use the depth thingy on it. That is 0.65. 0.165. So whatever depth that is. Now, if my hole isn't big enough, I'll crack the case. So I'm just going to do this by feel. This is a 5/32 of an inch drill bit that's pretty close to the thickness I need. Hey, buddy. I'm gonna back it out and just take a look. It's taking a little bit of force. That's how I removed this one from the old case, by the way. Just thread a bolt in there and whack it. It still feels a little tight, so I'm going to bump it up to 9/16. That feels nice and comfy. Okay. Good. We'll be able to run with all 4 bolts next time. Boy, if I'd taken that off first, it sure would have made this project easier. This is an area that I've been curious about because I was never really confident in how well this seated to the head, and I would have liked to have spent more time playing around with that. The other gasket looked better, but this one looks like it's compressed more here than here, so this may be our culprit with the vacuum leak. We're going to spend some time playing around with this. We did have a really big issue here. Once we were to the point where starting over was no longer an option, we just didn't have time. We cracked the case. We were tapping here for full flow. You can see we opted to go with an in-out filter after that point, but we were tapping for full flow. I pushed too hard and I cracked the case somewhere up in here. So this is a bunch of JB Weld that seems to be doing pretty okay. But there's some weeping oil down here. That could be coming out of the crack. I think that's most likely. But there's a possibility that this galley plug just needs to be tightened up a little bit. So I'm gonna clear some of the JB Weld off of just the head of this plug and see if I can snug it up a little bit. I'm not gonna do anything with this one. I've tightened that one just as much as I dared because I didn't want to open up that crack anymore. But down here, we've got good metal. And so we'll see if we can affect a little bit of positive change here. Okay, I think we broke the last bit of JB Weld from around the head of the plug. And I'm just gonna stop there, but that seems significant. We got a quarter of a turn in tightening that piece. May have very well been the source of this weeping leak. So I hope so. We're looking for half lift. Right now, I have the micrometer set up with the valve at full lift. So we'll see it come back up. There's 1/100, 2, 3. I'm not gonna go much further on this stock cam here. Okay, I'm gonna say that's 3/18 and a little bit of change. So 0.318 inches. Half lift will be half of that. So 159.159. So I'm gonna come back around. While we're here, I'm gonna go ahead and zero it to make this part easy. We'll go down from there. 100, 50. We're going backwards, but that's all right. Oops. I want to get right there on 41. That'd be a difference of 159. Okay, that's half lift. I believe that we're in good shape. What we want is the tip of the valve stem to run right through the middle of the rocker arm. So we want perpendicularity between the middle of the rocker arm and this line that I'm making with the ruler and the valve stem itself. And I think that's where we are. We also want to see that the adjuster, or the swivel foot here, is right centered on the valve stem. We want it to be right in the middle. That way it wipes across kind of the top to the bottom, but in the middle of its travel, it's on the center line of that valve stem. I think we'll get the most lift that way and the least amount of valve guide wear. I think this is where getting your valve train geometry right really pays off. This isn't a big surprise because this is mostly a stock engine, other than the heads being fly cut. Also, these push rods and these rocker arms and these swivel foot adjusters here, all this was set up on the Grenade engine previously, and we've just transferred them over here. and kept everything pretty much intact. So I figured they'd be pretty close, but wanted to check for sure. I'm going to take a look at the other ones as well, but I think we're going to be in good shape. Valve tray and geometry is good. We went ahead and adjusted the valves, got the valve covers back on, put the plugs back in. The long block is all set. Next up, we're going to do some work on the cooling tin. However, I want to start here. This, copper gasket here looks like it is not evenly compressed all the way around. In fact, it doesn't look like it's compressed very much at all right here. And this kind of tells the tale. This is our single port in castings. This is an aftermarket item if you haven't seen it. So you can run a center section from a dual port intake manifold on single port heads. But anyways, there we are. See how that cooling tin, just the very edge of it right here, it looks to me like it was holding this thing up. And that would cause a vacuum leak. So I think what I want to do is pull off these tins and just see if I can get this to seal as is, modify as necessary, and then we'll clearance the cooling tin as necessary to allow both of these ears a little bit of room to do their thing. This one over here looks pretty close. And then we'll do the same on the other side. I'm going to go ahead and remove the sled tins, but before I do, I want to show you something. This is the industrial tin that we made a long time ago. I'll link the video here. And it's been really nice, except that it didn't fit this engine. It fit the Grenade engine really, really well, but look at that gap. Like, it didn't even begin to fit this engine. So I'm going to take this off. And when we get to it, I'm going to try this out. This is an original industrial tin. It's much simpler. Let me see, just like this here. So we'll see if this fits any better than my custom dealy-do that fit really well on one engine. My guess is that this would fit most engines, but we'll see how that plays out. For now, we're just going to get this out of the way so we can do our work up here. I know a lot of us car guys have a love affair with brake cleaner, but just for the record, carb cleaner does a pretty good job too. That appears to be an issue. Check out this little boss here. Our manifold is bottoming out on that either before or about the same time as we get down to our crushed gasket here. That looks like an issue to me. All the single port heads have this on here. So if we're having a clearance issue, instead of grinding that down, it would probably be better to grind down the intake manifold, because this is the thing that I'm more likely to reuse. This is the sealing surface here. So as long as I leave that alone and it maintains a flat bottom to it, in fact, I could probably flat that a little bit. I think I can get away with grinding some of this off. so that it doesn't stand on top of that little nub there. This part of the gasket isn't even crushed. It's amazing the thing ran at all. Awesome. Okay, so we'll do that. We'll clearance this area here just in case. And then I think we'll just focus on the cooling tin to make sure these ears don't bottom out on it. We'll trim off just a tiny bit over here and a decent amount over here. Okay, this is a much better situation. I think we'll be able to avoid vacuum leaks this time. Look at this. This is pretending to be copper. There's obviously some iron in there. I don't want to go in this way because that's the sealing surface down there. Big pet peeve for me is gouge marks on sealing surfaces. So we'll go in this way. That way this down here, this important part, isn't damaged. Alright, things are going pretty well. Next up, we're going to clean these up, and I think we have some metal work to do on one of them. May be hard to see, but that's cracked. And eventually they'll get a coat of paint before we do a final install. But let's play around with these original industrial tins. So now that they're cleaned up, we found a crack here. Comes all the way down to here. You can kind of see it back here as well. But this is interesting. Different spot, but same basic location, just around this hole. We've got a fairly obvious crack there. So this must be a stress point in how these things get installed. I'm going to pay a little bit of attention to that when we're putting these things on the engine. But for now, let's fix them. We've got these welded up, I forgot to hit go on the camera, and I forgot to turn on my welding gas, so I made kind of a mess here. But we're fixed, and we're moving on. Well, honestly, not all that impressed. It's better than the last set, but that's not saying much. That's a lot of gap, and that's a lot of gap. This is where we have to decide how much we want to put into this. Let's put the old set on and see what that looks like. See if they can be modified or something. What I liked about these is this piece extends up, and that helps along this area here. Actually overlaps with all of this. It just did not even begin to fit that great. I mean, this looks way, way better. So with the exception of a big hole here, I could just drill new holes, right? This is where the holes are now. I could drill new holes further back, scoot this up, and then I'd just be missing a big hole here. I'm gonna think on this one a little bit. Okay, looking at the homemade one again, I've decided that I like the way this one fits better than the OEM one, but it does not fit well enough. So we're going to use this as a template to make a whole new one. We could probably make it taller, and that would make this easier. But mainly what we'll be doing is following the contour back here. So we've got this huge gap back there. It'll make this turn a little sooner and come up this way and end up right about there. That ought to work. So if this is going to be necessary, I'm not certain of that, but if this is going to be necessary on each engine, I don't mind the idea of having a collection of them that all fit just a little bit different. Because that's kind of how it goes with cooling tin. I did test the OEM one against other sled tins that I have laying around, and all of them had basically the same problem. So it's also possible that this one is wrong and the one that we make today will be more compatible with other sled tins. But this is the engine I'm working on today, so this is what we're going to focus on. Not really fond of this gap either. We could probably hammer that closed. This one we're going to go about 1/4 of an inch further. I should put this pattern in a safe place. I don't remember where I put the old ones. They're somewhere. So we'll be cutting out a good portion of this. Actually be cutting out more than that, but I want to leave this strip so it follows that curve. This is the part that we'll be welding together. You can see all my old spot welds there. So okay, this will all be extra here. Let's just go this way. Get that out of our way. So I'm expecting to start here and maybe end up right about here, so, but we'll mark that actually on the engine. Is that right? Yeah, something like that. Or about 1/4 of an inch taller. Like that. And I think I'd like to mark those holes. Make sure that's empty. That's cool. I'd be much happier with this. I have a little gap here. But yeah, I think I like the way this comes up here too. So we'll weld up to this point and let this flap stay outside maybe. Because it's underneath all of this, it needs to stay outside. But maybe don't cut it off and just let that be a clip to kind of slip things in place. Yeah, let's find some sheet metal. Mark this up, cut it, bend it, see where we are. Okay, we'll do 3 bends. That's what we're looking for. Okay, I got to remember not to weld to the end. So I need to stop about 1/4 inch shy, maybe 1/2 inch. We'll just weld from there to about right here. Still need to drill a hole here for safety wire. In fact, I think I want to mark that. Okay, so if we've tightened everything, this is safety wired in place. I'm happy with that. That's good. This is all exhaust air. The point is that we want it to come out of the back of the engine. I think that's especially important in my case because I don't have the aprons on the side since Dweezil is open in the rear. That clip and the deck lid and all that back here, that seals off the intake air to cool air that's above the road. All of this makes sure the hot exhaust air goes below all of that and behind the vehicle as you travel instead of recirculating around to go into the intake. So this is not as critical here. I'm not sure it's critical anywhere, but this little gap here would not be as critical here as it is higher up in the system. So I'm going to go with this. Let's drill that hole and move on to something else. I've been playing with this set of thermostat flaps, and this one was binding. I've gone ahead and lubed it up a little bit. There's no real great way to do that, so I'm just going to let it be a mess, and that's fine. But it was binding here. I think somebody refurbished this stuff, and so maybe it was just paint. But I pulled these off, filed the inside of those bores just a little bit, and now it moves better than the one that wasn't binding. I'm satisfied enough with this to do the other one. It's not much, but it's what I can do. probably do a good job of collecting crud. Honestly, I think all the fumbling around that I'm doing right now is why people don't like using a thermostat. We say things like we're in a warm climate, which, okay, but a warm climate to people is not the same as warmth to an engine. So it's a false logic to me. What we're trying to accomplish with the thermostat is to warm up quicker. Our engines are pretty loose when they're at ambient temperature, even in a warm climate like our adorable 96-degree summers here. Heat to an engine is much hotter than that. It's hundreds of degrees, and there's parts of an engine that are 4 figures. For example, the exhaust valves. But we're trying to warm up this engine with that level of heat, like what's radiating off of the cylinders and coming out of the oil cooler. The faster that we can heat this thing up, the faster it'll expand and seal the cylinders against the cylinder heads. Yes, that'll happen anyway, because eventually the vanes do open up all the way. But it happens quicker if we're controlling the flow of cooling air with a thermostat. On top of that, I think these vanes, they do provide some back pressure, which is part of the argument against them, that you'll flow more air to the cylinders and the heads. Without them, that may be true, but some back pressure here and here would, seems like, send a little bit more air through the oil cooler, which is also very important because that cools the engine. Our heads are not just air cooled, they're oil cooled, and so we want to remove that heat too. That's how it was designed. I'm sure they thought of all of that to whatever extent it matters. So there's a lot of people that I like and respect that throw the thermostat away. Fine. I would not propose to tell someone else what's right for them. This is definitely right for me because I can tell a difference. Meaning, I think an engine that is warmed up runs better than an engine that is not warmed up. And my drives are usually pretty short. These days I live pretty close to the places that I need to go. So without a thermostat, the engine hasn't really warmed up by the time I get where I'm going. So I'm missing out a little bit on the best running engine that I can have the way that I use my car. So I want to warm up as quick as we can. I'm a big fan of including the thermostat, and I don't care what kind of climate I'm in. I just don't think that matters compared to the reasons that it was put there in the first place. So there's my 2 cents. I know there's probably a lot of folks that are certain they're not worthwhile, and they've gotten whatever kind of results for however long, and I'm not going to question any of that. Here's one side of the story coming from my shop. These pieces have been drying overnight and they're just about ready, so we can go ahead and start assembling the cooling system. One more step here. We need to seal the oil cooler and the doghouse area here, so we'll put some foam weather stripping on the oil cooler itself. The original is long gone. Also, I'm going to put a little bit on this piece too. We're going to go here on the doghouse itself. And a little strip here, but we'll put that right on this. I don't know why this is here, this little indented part, but I'm gonna put some weather stripping on that to help seal that gap, because otherwise, that's what it would be. There'd be a hole there. I'm not sure why that's there. I've never figured it out. So if you know, let me know. But for today, we're gonna seal it. I have some old camper shell weather stripping here. I'll use this. I don't typically find this adhesive to work well, so we're going to use a secret weapon. Let me see, we'll probably put some across here and across here, and then at least one layer going up each side. This is 3M very high bond double-sided tape. This stuff is reliable, so we'll cut off just enough, go across the top. So if the tape can hold as well as its backer did, that'd be nice. That looks like that'll do it. Here's one of those fun things that happens when you're in too much of a rush. I did not tighten this down enough, and so it's actually wallowed out. It came loose, and it's, right, it does this. And that's probably not awful for a stock engine. We'll save this one for one of our humble builds that we do. It's just mangled a little bit, so that's a real shame. This is otherwise a good stock doghouse, like the wide one, right, fan. So we painted up another one we had in our stash that's in better shape, and we'll just have to make sure to tighten this one. No play. Boy, these are weird parts, aren't they? Wish I'd remembered to paint that. That's all right. All right, I didn't remove this from the backing plate, so it should be all set, but we want this opening to face down in here where there's a little bit of clearance. So when we put the generator on the backing plate, we want to clock it such that the terminals are easily accessible over here. We did replace all of our 10 screws with hex head bolts. They're just 6mm, I think a 1.0 pitch. Yeah, and 12mm long. I am quickly becoming a fan of these slide handles. I've had them and used them for a long time, but I find myself reaching for this more often. I've always been kind of a combo wrench guy. I don't gravitate towards socket wrenches and especially battery operated stuff. I like to feel the fastener, and combo wrenches are nice and basic and reliable. I'm starting to like this too. These little holes are right at a 1/2 inch in diameter. One of them is going to be for the throttle. That's going to be this one here. So this little tube passes through there. Whoa. Looks like it passes all the way through there, which doesn't seem right, but okay. This one, I think, is best used to lose tons of air pressure. So I have an old little spark plug wire clippy clip that I'm gonna plug the hole with it. And I have some new ones that we'll use. So we'll go ahead and get them inserted. Aftermarket parts, folks. Oh, cool. Have some little horns on there that don't want to cooperate. This is a great time to get in a hurry and skip steps that we'll wish we did later. One of those is a little bit of anti-seize on all of the tinware screws. Like, why wouldn't we do this? Especially on the cylinder heads. So I just keep some copper anti-seize handy and hit every one of them with a little bit of it as we assemble. We'll make disassembly, like if this engine runs and runs and runs and we get to use some parts again someday, it sure will make it easier to pull it apart and salvage that stuff. Okay, let's see if we can make it run. Gonna leave the ignition off so we can build some oil pressure. So we'll be watching this light and this gauge. I guess that's a good sign. The gauge is going up. There we are. I'm going to let it get out to the heads. Okay. Fire in the hole. Looks like we have fuel. Quick tip, these little rebuild in a bottle dealies like seafoam and whatnot make really good emergency gas cans and pretty helpful when you're trying to start an engine too. been tuning for a little bit with the 34 pick 3, so we started each of the screws, the bypass and the idle volume control screw, out 2.5 turns each. And what I'm finding is I need to open up the volume control screw and close up the bypass screw more than I want to. So I don't know if that's just a worn carb or something that I can fix with what's here. So I'm going to ponder on that, but for now we've got it idling. It's idling a little high. That's kind of a fix for something that won't idle like you want it to. But it's not bad. We actually backed off on the accelerator pump. It would stumble on acceleration, and I tried to increase it, which didn't make it any better, so I thought maybe I'm flooding it, and I backed off one of the clicks on the little arm. So I've leaned out the accelerator pump and it doesn't stumble off idle anymore. So that's pretty cool. Anything that means less fuel is good with me. So let's hear it. There is one concerning thing that I noticed is there's a miss on the 1-2 side. And when I go to high RPM, I bring it up. Well, this is saying about 5,000, but it's really about 3,800. So my tac's not so great. When I bring it up to high RPMs for a sustained amount of time and then dump it, I get smoke out of this side. So maybe a ring, maybe some rings aren't seating very well over there. Let's show you that. That's going to be drivable. Okay, watch this one. Yeah, a little bit of white smoke over there. Old parts, what are you going to do? I think I'm going to let it cool down, throw it in the car, we'll drive it a little bit, go from there. It's the next day and we're back at it. I was able to do a lot of testing yesterday. Never really got the carb where I wanted it to be. I think the volume control screw is too far out and the bypass or the idle setting screw is too far in compared to base settings. This is one of those deals where everything else has to be right, like timing and valve adjustments and no vacuum leaks and so on. Before we can get the carb to really do its thing. So we'll put a new set of plugs in it. I tried a new set of wires, that didn't help. And we'll just see where it goes from there. I do have another carb that may be in better shape than this one, so I can clean that one up once we have the engine in the car, and that'll be easy to swap out. Sometimes that's how it goes when you need the car to be on the road and you only have so much time. You do what you can and you keep coming back to it. So that's how we're going to proceed. I have really enjoyed the engine start panel here. It worked beautifully. I didn't have any problems with it. I really enjoyed this thing and it looks pretty cool. But for now, let's get this thing off the stand and in the car.